Hello viewers, welcome to my channel AK Concepts of Electrical Engineering.
Capacitance due to two concentric spherical conductors. Inner sphere having the radius A, whereas outer sphere having the radius B, and the space between these two spheres is filled with the dielectric material having permittivity of epsilon r, and outer sphere is grounded. Inner sphere is having a charge Q on its surface due to the voltage given to this. Now consider a radius r, and this is, let it be, a Gaussian surface. By the Gaussian law, total flux is equals to charge Q. Then flux equals to integral d dot ds closed surface, where integral is ds equals to 4 pi r square since it is a sphere. Then total flux equals to d 4 pi r square, which equals to q, and d equals to q by 4 pi r square, and we know d equals to epsilon e. From this, E equals to d by epsilon. Therefore, E equals to q by 4 pi epsilon r square. Now we know E equals to minus dV by dr, from which dV equals to minus E dr. Now substitute the value of E, that is minus q by 4 pi epsilon r square dr. This is a dV. To find out V0 to V, which equals to integral e to a q by 4 pi epsilon r square dr, from which V equals to minus q by 4 pi epsilon and 1 by r square dr integral b to a, from which minus q by 4 pi epsilon minus 1 by r, that is b to a, that is minus q by 4 pi epsilon 1 by b minus 1 by a, from which v equals to minus q by 4 pi epsilon a minus b by ab. Now this can be written as v equals to q by 4 pi epsilon b minus a by ab. Now we know the capacitance C equals to q by v, that equals to q divided by q 4 pi epsilon b minus a divided by ab, and q gets cancelled. 4 pi epsilon ab divided by b minus a is our capacitance C in farads. Capacitance of isolated sphere or charge, B is tends to infinity, then a by b equals to 0. C equals to 4 pi epsilon a by 1 minus a by b. I can write this equation in this form. Then this term will become equals to 0. Then C equals to 4 pi epsilon of a farads. Let us solve our problem. Find capacitance of parallel plate capacitor if the area is 1.5 meter square and the distance between the two plates is 2 millimeters and potential gradient is 10 to the power of 5 volts per meter, and the charge density rho s equals to 2.5 microcoulombs per meter square. Then we need to find out the capacitance C, which is given by A epsilon by D, where we know the A, we know the D, but we don't know the epsilon, but we know the formulas that D equals to rho s, which equals to epsilon E, and dV by ds, that is potential charge density, equals to E, from which epsilon equals to rho s by E is nothing but rho s divided by dV by ds, which is given by 2.5 microcoulombs divided by 10 to the power of 5. When you solve this, epsilon equals to 2.5 into 10 to the power of minus 6 divided by 10 to the power of 5, 10 to the power of minus 11 farads per meter. Then C equals to A is 1.5 and this is 2.5 into 10 to the power of minus 11 divided by the thickness is 2 10 to the power of millimeters, so minus 3.75 into 10 to the power of minus 11 divided by 2 into 10 to the power of minus 3, 1.875 into 10 to the power of minus 8 farads. C equals to 18.75 nanofarads.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.